Good afternoon. Today, actually, in the last class, we have discussed up to combination of transistor and operation of transistor with the help of operation of diode, because diode is transistor is a combination of two back-to-back diode. Okay, mechanism of internal transistor we can easily understand with the help of diode. Today, I'm going to start the transistor operation with the help of the internal mechanism similar to the diode. Okay, so transistor there is a two type of transistor. One is NPN transistor, one is PNP transistor. Whatever it is, whatever it is, PNP. If we consider PNP transistor, how it is work. So it is considered PNP. This is PNP transistor. PNP. So PNP, this is a base region, and this is very thin. Okay, collector. This is P, this is N, and this is P. Okay, and this is a base terminal. Okay, this is a collector terminal. Now, how can you understand? How can you understand this is earthing grounded? Okay, this is NPN resistor. Okay, this is positive side. So forward input circuit, that is input circuit means P and this circuit. Input circuit means this circuit. This circuit is input circuit, and this circuit is known as the output circuit. This block. Okay, and this is P side. So input circuit is forward bias. Forward bias means this P is connected to, this is positive, majority carrier here positive, so it will be positive, and it will be negative. This is positive, this is negative. Okay, and output circuit is a reverse bias. Reverse bias means this is P side is connected to the negative. Negative, this is positive. Okay, this is PNP configuration. Now this here majority source is, majority carrier is hole. Okay, minority is electron, and this is a positive, and ion, negative ion is also there. Okay, maximum positive, minority is negative, maximum positive. So majority charge is plus hole, and minority, small minority electron is there, and this circle negative means negative ion. Okay, similarly it is N type. Okay, N is a majority of electron and minority hole. Here similar to this other side, negative, positive, positive, negative, negative circle, positive, positive. Okay, now this is positive, this positive. So majority is positive, it will move to this side. Okay, majority will, because this positive and this positive repel each other, so hole will move this side, and as a result electron will move this side. This side here majority is electron, minority is hole. Okay, now as a result of this repulsion, okay, small depletion region is created here. Small depletion. This is a depletion region I have already discussed. Okay, and this is forward bias. Because of forward, this is positive and this is negative, is connected to negative, so depletion will be thin, as I have mentioned in the diode application. Okay, but in the reverse bias, this is positive connected to positive, this is connected to negative, reverse bias, so depletion region will be very high here. Okay, so there will be T current. So hole will move this side, electron will move this side. Okay, so electron will move this side, so current direction against the direction of electron. So I, this is emitter current, is along this direction. Okay, this you can simplify this way also. If you confuse, this is transistor, this is collector, and this is emitter. Okay, and this is a base. This is a base current IB. Okay, now emitter current I is inside, so IC and IB already outside. So this circuit is connected. This is positive, negative. This is positive, negative is connected to outside. This is output circuit. this is input circuit. This is for PNP transistor. Okay, so again I am telling this positive side majority is hole, so hole will move this side, electron will move this side. As a result of electron will move along this direction, and the conventional direction of current will opposite to the direction of electron. So current emitter direction this one, and if the emitter is inside, then IB and IC will be outside. This is a graphical representation. So now simple, if it is if it is now it is for PNP transistor. Okay, now if I connect it, see if it is NPN transistor, you see NPN transistor, so it is simple also. This is base region, this is base, so this is NPN. Okay, now this is negative, majority is electron, minority is hole, and small donor ion will be there, donor ion, majority electron. Okay, this one circle, there is a not one circle, there is a many small circle, so maximum number of electron is there. That is why it is n-type semiconductor. Okay, this is n side, so I will. It must be input circuit must be forward bias. So that is why I have to connect it negative. This is negative, and this is for hole grounded, and this is negative, similar to this maximum majority electron, minority hole. Okay. This is negative, this must be reverse bias, so this is connected to the positive and this is connected to negative. This is output circuit and this is input circuit. Clear? So in that case, so this is this diagram you OR, this is OR, okay, do not confuse. This is transistor, this is negative, and NPN transistor, not to point in, so emitter current will be outside, not to point in, emitter current will be outside. So this is negative, this must be negative, this must be positive, and this is a reverse bias. So I will be IC, IB, this is negative, this is must be positive. Okay, you can represent like this, you can represent. This is the internal mechanism how it is operated. See, this negative and negative charge, it will push the negative charge toward this direction. As a result, hole will move this direction, electron will move this direction. So direction of current will be opposite to the direction of electron, movement of electron. So electron move this side, so current direction will be out. Okay, this is the type of transistor mechanism. So now you focus on the better this diagram, whether it is NPN or PNP, whatever it is. So whatever, this is NPN transistor, PNP transistor, it will represent like this. This is PNP transistor, this is P and P positive, so it must be positive. This is ground, and this is IE, it is IB, it is IC. It is reverse bias, so this is positive, this must be negative. This is output circuit, this is input circuit. Clear? Whatever it is, whether it is NPN or PNP transistor, if you focus on this diagram and Kirchhoff law, then what happens? What is the Kirchhoff law? Kirchhoff law is algebraic sum of current is equal to 0. Algebraic sum of current meeting at a junction is 0. Or you can see, this can be, you can better explain. So IE is positive because it is toward the junction, and IB and IC will be negative. So it is negative. Why negative? It is away from the junction. So finally you will get IE equal to IC plus IB. Clear? Similarly here also, if you focus on this diagram, so total current, sum of current meeting at the junction is 0, algebraic sum, okay? Then IB is positive, plus IC is positive and I is away from the junction, it will be negative, is equal to 0. So I equal to IC plus IB. So what you can understand, irrespective of any configuration, whether it is PNP transistor or NPN transistor, total current IE is equal to IC plus IB. And remember, the input current is either IE or IB, but output current is always collector current. Remember, okay? This is the basic mechanism of transistor, two type of transistor, NPN and PNP transistor. Now I am going to focus on different combination of combination of transistor. What are the different combination of transistor? There are three type of combination. One is common base collector combination, and one is a common emitter, one is a common collector. Okay, common base and common emitter combination is used for amplification purpose, and common collector and normally used for impedance matching. Okay, so T combination is there: common base. Okay, I am not writing full form. Okay, and common emitter. C stand for common, E stand for emitter. And third combination is common collector. So what do you mean by common base collector? First I will discuss. First discuss common base connection. Okay. So common base combination, I will common base combination. Why it is called common base? You see the diagram. I am writing the simple diagram. Okay. This is you can write NPN or you can write PNP, whatever you like. PNP. Okay. Nothing will change. Only representation. N side, this is N side. N side is, it must be, input circuit must be forward bias. So it will be negative, so it must be negative. Okay. And this is connected to ground, earthing connection. Okay, this side, this is input circuit. Okay. And this is output circuit, and output circuit is reverse bias. So it will be negative N. So it will be positive, negative, positive. This is common base connection. Or if you confuse, you can write this way also. Same thing. Okay. This is base, this is base, this is collector, this is emitter. Okay. And this is NPN transistor. Okay. This is negative side. So you have to input circuit must be forward bias. Forward bias means it will negative is connected to negative. If it is positive, then it will be connected to positive. Okay, same polarity is connected. This is negative polarity, and I will connect a negative polarity. Okay, and this is the base region. This is ground, earthing. This is reverse bias. This is negative side. Negative side is connected to positive. Okay, this is output circuit, and this is input circuit. Clear? Now direction of current, how you can identify. Not to point in. Remember, not to point in means emitter current will be outside. If emitter current is outside, then base current IB and IC inside. Okay. And once you know the direction, once you see the direction of current, if emitter current is outside direction, then you can easily identify it is NPN transistor. Okay. So it will be IE, and it will be IC, and it will be base current. Same diagram. Or okay, do not confuse. Now why it is called common base? This is input circuit. Input circuit is this part. This side is input circuit. Okay, this side is input circuit. This part is input circuit. Okay, this part is input circuit, and this part, this is a common. This part is a output circuit. Okay, this is input circuit. This is output circuit. Now, why it is common base? Base terminal is common to both input circuit as well as output circuit. That is why it is called common base. Clear? Okay. This is common base. Okay. And forget about this connection. And I have already told this. Whatever you can write this diagram also. I am writing again this diagram. Simple way I can write. This is NPN transistor, emitter, base, collector. This is negative. This is positive. And this is negative connected to positive. This is negative. This is output circuit. Okay. This is input circuit. This is emitter current will be outside, IC will be inside, IB will be inside. Clear? Or you can simply write this way also, no problem. Whatever it is you want to like, negative, positive. This is the base terminal, ground. This is output circuit. This is input circuit. This is emitter current, this is IC, this is IB, or okay, or. So base terminal is common to input circuit as well as output circuit. That is why it is common base combination. Okay. Now question is that what type of input characteristic and what type of output characteristic we can get. So input characteristic is that into common base connection input parameter. What are the input parameter? Input circuit, what are the input parameter? That is, one is the output emitter current. This side is a variable parameter is emitter current, and then it is what is the voltage? Base emitter base voltage, VBE. Is it? V voltage, base emitter, base and emitter voltage. This is known, and this voltage base CB. Collector base voltage VCB, VEB. Okay. So input characteristic of common base configuration is like that. So when you can get an emitter current, once we apply the biasing voltage here, then we will get an emitter current. So emitter current will be IE direction. And this side is VBE, base emitter voltage. So it will be like this. So specific voltage, this is suppose VCB 1 volt. VCB means for particular voltage, for a given voltage of VCB, collector base voltage, suppose 1 volt, I am getting emitter current like this. For suppose this is VCB equal to 2. So input characteristic is the characteristic between emitter current as well as base emitter voltage. Okay. So output characteristic of transistor, I am removing this part. So it is same. So output characteristic will be, so output characteristic VCB. Is it okay? VCB. This is a VCB and this is IC, collector current. Okay. Collector current normally fall in the milliampere. Remember, collector current normally fall in the milliampere, but base current always fall in the microampere or nanoampere. The emitter base IV current is very less as compared to emitter current and collector current. So it will be negative. So if you plot this output characteristic IC and VCB, so how can you get? So you can take a transistor, okay, and apply the voltage. You collect the data, emitter collector current for a specific voltage of VB is equal to 1 volt, VB is equal to 2 volt, okay, or emitter current specifically this amount, then you will get a curve. You will get a curve like this. One curve is like this for emitter particular voltage. So specific voltage emitter value is 0 ampere, So emitter current is equal to 1 milliampere. Emitter current is equal to 2 milliampere. Okay. For specific value of emitter current is the input current. So if you plot, if you collect the data, output collector current corresponding to VCB voltage, you will get a plot like this. Okay. This this is the maximum current, is known as the saturation current, maximum current. And this region, after beyond this region, if you increase the VCB voltage, the output current remains steady. So collector current will only increases. This region, you see, this region is known as the cutoff region. Cutoff region. This region is cutoff region. Okay, and this region is saturation region, and this region is active region. Okay, there is a three region in transistor operation: cutoff region, saturation region, active region. So in active region, this is the active region, this side, above this side. So in active region, okay, input circuit is forward bias and output circuit is reverse bias. Okay, but in cutoff region, this is called cutoff region. In cutoff region, in both input circuit and output circuit will be reverse bias. Okay, and both in last saturated region, both input circuit, this circuit and this circuit, are in forward bias, positive polarity. Okay, these are three region, operating region of transistor. One is the active region, one is the saturation region, one is cutoff region. In active region, input circuit is forward bias, that is known as base emitter. Base emitter junction is forward bias, collector base is reverse bias in active region. In cutoff region, base emitter junction is forward bias. What do you understand? So suppose in order to apply your transistor, suppose transistor is a T-terminal device in cutoff region, then what happened? Then input circuit, now it is negative. Okay, we are connected negative, so both are reverse bias. If you want to apply this transistor in cutoff region, then this is negative must be connected to positive. Okay, similarly this negative is connected to this is already reverse bias, and this is also become reverse bias. Okay, but in saturation region, both are forward bias. Suppose you want to apply transistor in this region. In this region means you want to get the value collector current within this range. Then you have to this is forward bias, this is now reverse bias. Then it will be negative, and this will be positive. Both are forward bias. But if you want to apply transistor in active region, normally it is amplified. In order to amplify a signal, so transistor must be active region. Active region means input circuit must be forward bias and output circuit must be reverse bias. Input circuit means base emitter junction must be connected in forward bias condition, and collector base junction must be connected in reverse bias condition in active region. Okay, so depending on our requirement, we will connect the transistor as per our requirement, and we will apply for that. Okay, this characteristic diagram for transistor, there will be two characteristic. One is the input characteristic and one is the output characteristic. Remain same for whether it is common base, whether it is collector, common collector, common emitter. Okay, so I am not going to discuss that part. Next one, common base connection. So in common base connection, I am drawing again, so that in order to confuse, this is I am going to apply. Now question is that I am going to calculate the current amplification factor. So I want to amplification factor means I want to apply transistor for amplification purpose. Okay, then if I want to apply the transistor in amplification purpose, I have to apply in active region. So according to active region requirement, so in base emitter, it is what? It is emitter. This is base and this is collector. So base emitter junction must be which region? Must be forward. Forward. This is NPN resistor. NPN resistor. This is negative. So it is not negative is connected to negative and positive. It is forward bias. Similarly, this is input circuit. Input circuit. This is a ground, and this is output. Base collector junction must be reverse bias. This is negative, so I will connect it to positive and it will be negative. Okay, positive, negative, positive, negative. This is VCB, VCE, sorry, A to VCB. Collector emitter, VBE, base emitter voltage, and VCB collector voltage. So, in order to apply transistor in amplification purpose, we have to apply active region. According to criteria of active region criteria, input circuit must be forward. Is it okay? Negative is connected to negative, positive is connected to positive. That means forward bias. And output circuit must be reverse bias. Negative is connected to positive, opposite polarity, and positive is connected to negative. That means it is reverse bias. Is it okay? Now, this is output circuit. And this is NPN not to point in. So emitter current will be I outside and IC inside, IB inside. So what is the input current? Base current, this is a common base configuration. Base current is not considered input current because base terminal is common to both input circuit and output circuit. So what is the input current? I, and what is the output current? Output current is constant, always IC. Okay. So in common base configuration, the current gain factor is always represented by alpha. Alpha equal to output current divided by input current. Okay. So IC equal to IC plus IB. Is it okay? I equal to IC plus IB. So, so when base current is 0, then if IB is equal to 0, then alpha equal to 1. But practically, IB is not equal to 0, although it is very, very small. Suppose IC in milliampere current in transistor we are getting. So emitter current we are also getting IA. If IC is milliampere, IE is also milliampere, then IB is normally microampere or nanoampere. But it is not become 0. So in that case, alpha is less than equal to 1. When IB is 0, then alpha equal to 1. So if IB is not equal to 0, then alpha is less than equal to 1. Remember. So alpha is a current gain parameter, is output current divided by input current. Output current is IC, always fixed, and input current is I. Clear? And what you can see, even IB is 0. Suppose you theoretically IB is 0, there is no base current. Okay, then alpha equal to 1. That means there is no current gain. Input 1 means what? Output current equal to input current. Whatever you are giving at the input terminal and the output of transistor, you are getting same value. So there is no gain. Okay, common base configuration. That is why normally not used for practical purpose. Clear? This is the condition. Now I am going for common emitter. So common emitter combination. Two combination common emitter. Common emitter combination. What type of common emitter? Common emitter means emitter terminal is common. So how can I write? So common emitter configuration I will write like this. This is PNP, suppose NPN transistor. So NPN. C base emitter. So emitter terminal is common. You see, this is base positive, so it must be forward bias. If we use this in amplification purpose, if positive is connected to positive, and then E, this is NPN. So it is negative. Negative is connected to negative. This is input circuit, is forward bias. Okay. This is what collector is negative. It must be reverse bias. Reverse bias means negative is connected to positive. So this Clear? So what you can understand, this is output circuit, this is input circuit. Now this is emitter. Emitter is common to both output circuit as well as input circuit. That is why it is nomenclature as a common emitter. Emitter terminal is common to both input circuit and output circuit. Okay. Now in that case, what is a big this this is a not to point in. Emitter current will be I, this direction. So collector current I, C, and base current will be IB. Okay. This is in case of NPN transistor. If it is PNP, all diagram will remain same. PNP, P and P. Then it is, if it is N, you see the difference. If it is N, P and P, PNP pins. This is P, collector. This is base, N. This is emitter. This is P. Okay. Same diagram, this is negative. Now what is the negative polarity? If it has to be positive for forward bias, the same polarity is connected. Same, this is what negative polarity, I will connect it to negative, and this will connect it to positive. So it is grounded. Okay. Now it is output circuit. Now it is what positive. So it must be output circuit must be reverse bias. So we have to connect it opposite polarity. It is positive. Majority is positive, that is why it is called positive. So I will connect negative. This is positive. This is output circuit. This is input circuit. Now you see, diagram is same. Only connectivity is different. So here this is P positive. Majority is positive, so I will connect it positive. Okay, and this is negative, so negative is connected. That means it is forward bias. And this is negative, so negative means output circuit must be reverse bias. Negative is connected to positive. Okay, and this is negative is connected to negative. It is reverse bias. Only the polarity is different. You see this diagram. And this is pointing, P and P pointing, emitter current will be inside. Okay, if emitter current is inside, then collector current outside. Collector and base current will be outside. Okay. Similar to common base connection, it has a input characteristic, output characteristic. Same diagram you will get. So that is why I am not drawing that diagram. Okay. Again, this is PNP transistor. This is NPN transistor. Again, I am telling, if it is NPN transistor, emitter, first thing, why it is called common emitter? Because emitter terminal is common to input circuit as well as output circuit. That is why it is common emitter. Number one. Number two, if it is NPN transistor, not to point in, that means emitter current will be outside. If emitter current is going away from the transistor, this semiconductor, then collector current will be inside as per Kirchhoff law. Okay. And this is positive. So input circuit must be forward bias for amplification purpose. This is positive, so it is connected to positive. Same polarity, if it is connected, then this positive pole repel the positive. Okay, then replacement with is small. Okay, same polarity is connected here, and this is negative become this input circuit become forward bias, and output circuit must be reverse bias. So it is negative is connected to positive, then opposite polarity, and this is negative is connected to positive, and this is negative. So it will be reverse bias in PNP. And PNP transistor, this is negative is connected to negative, same polarity, so it will be forward bias. And this is negative, this is positive is connected to negative, opposite polarity, it is reverse bias. Okay, this is NPN, PNP transistor, this is NPN. You can take any one of them, no problem. Okay. I remove any one, suppose I remove this part. Whatever it is, NPN transistor, PNP transistor, output current is IC. Output current is IC. What is the input current? Base terminal emitter current cannot be input current because emitter current is shared by output circuit. Input circuit, input current is IB. Output current is IC. So common emitter current gain factor is represented by beta. So beta is output current is fixed IC divided by IB. Okay, So this is the relation. Now can you tell me whether beta is very greater than 1? Because I have told you, if collector current is milliampere, then IB normally microampere or nanoampere. So I'm just giving an example. This is milliampere, this is microampere or nanoampere. So what happened? Any number divided by very small number, that means it will give a very high number. So beta is very greater than 1. Okay, normally it is 200, 300, 250, 100, 150 like that. Okay, so this is the relation. This is that we are getting two gain parameter. One is alpha, that is alpha is always associated with a common base, and beta is always associated with a common emitter connection. Okay, so what is the relation between alpha and beta? So how can you understand? Suppose we know. You can no need to remember, just we know this one, IE equal to IC plus IB, and I'm writing again alpha equal to IC divided by IB. Is it okay? If I divided both sides IE divided by IC, both sides divided by IC, then it will be 1 plus 1 IB by IC. Is it okay? So I can write IC divided by IE. Is it okay? 1 plus 1 by IC divided by IB. So IC divided by IE equal to what? Alpha. 1 by alpha equal to 1 plus 1 by beta. Okay? So what we can understand? So alpha, 1 by alpha equal to 1 plus 1 by beta. So 1 by alpha equal to beta plus 1 beta. So alpha equal to beta plus 1. Okay, this is the correct ratio. Suppose in exam, for net gate, any competitive exam, it is shown that which of the following is the correct relation between alpha and beta. One thing you would remember, alpha must be less than equal to 1. Now see, beta is suppose 50, then it will be 51. So it will be less than 1. Okay. Suppose I am giving an example. Beta minus 1 relation. Whether you have to answer which one is correct, this one is or this one. You see, beta is 50 suppose, then it is 49. It will become alpha equal become greater than 1. So it is wrong. Okay. So beta is 50 plus 1. 50 divided by 50 plus 1, it is always less than 1. So this is the relation between alpha and beta, and this is how you have to ensure whether it is correct or wrong. Okay. This is two combination. Now whatever we have, one thing you remember, whatever we are doing here, this is all DC analysis. DC analysis, suffix of any current, that is we represent IE. It is suffix is capital letter. This is not necessary, but conventionally we use for DSC analysis suffix is capital letter. For AC analysis we write like this. This is for AC, and this is for DC analysis. Whatever we are doing calculation, this is only for DC analysis. Okay. And last one is a common collector. Last one is a common collector. Common collector, very easy. You take a diagram. This is, you can choose any type, NPN also, no problem. NPN, and this is emitter, this is base, this is collector. Why collector down? I am telling you. See. Output circuit, input circuit, this represent like this input circuit. Now this collector is a common to both input and output circuit, that is why it is common collector. Remember, common collector normally not used for amplification purpose. It is it is used for impedance purpose. Since it has high input impedance and low output impedance, in common base and common emitter connection, it's a low output. In previous two example, it has low input resistance, high output resistance in common base and common emitter. But it is reverse in common collector. It has high input resistance and low output impedance. Okay, reverse of common base and common emitter. And common collector is normally used for impedance matching. What impedance matching, I will tell you later. Okay, and this is what the transistor mechanism and type of T transistor. Okay, combination. So most important parameter you have studied, there is alpha and beta. So alpha is associated with the common base and beta is associated with the common emitter. So beta is very greater than alpha as compared to alpha is maximum value of alpha is 1 and normally it is always less than 1.98, 0.80. Okay, so last one what we can understand. So transistor is represented by like this. This is represented as a transistor. Okay, this is a transistor. Finally what we can understand, specification of transistor. If you buy any IC, so there will be specification, it will mention everything. Specification means operating voltage of transistor, operating current of transistor, maximum power rating, maximum power voltage, that's everything will be mentioned in that diagram. So if it is transistor IC, so we have to see the specification. Suppose it is voltage is given 5 volt, that means operating voltage of this IC is 5 volt. Okay, you cannot connect this transistor directly to the board, electrical board, because it is very high voltage. Okay, we always in laboratory we always use battery 1.5 volt or 5 volt, 4 volt, something like that, in order to observe the functioning of a transistor. Okay, this is known as a specification. So transistor is a T-terminal device. Terminal T is collector, terminal 2 is base, terminal 1 is emitter. Remember. Summary of a transistor. Transistor is a T-terminal device. It is known as a bipolar device because current is contributed by electron as well as hole. Okay, and there is a T combination of transistor. One is common emitter. Okay, common base, common collector. Common base and common emitter is normally used for amplification purpose, and common collector is used for impedance matching. I will discuss later that part. T combination. Okay. Why it is common base? Because base terminal is common. Common emitter terminal is common to both input and output circuit. Common collector terminal is common to both input and output circuit. Okay, whatever the combination it is, total current is emitter E is equal to IC plus IB. So maximum value of current is emitter current, then collector current, then base current. Base current is the smallest value. If it is milliampere, it is also milliampere, but base current is always following the microampere or nanoampere. Remember. Okay. This is, and operating of transistor can operate 3 region: active region, saturated region, and cutoff region. In cutoff region, both input circuit means emitter base junction is reverse bias. Now output circuit means collector base junction is reverse bias. Both emitter circuit as well as output circuit are reverse bias in cutoff region. In saturation region, both emitter base junction is forward bias. Input circuit is also forward bias. Output circuit is also forward bias. In active region, emitter base input circuit is forward bias. Output circuit is reverse bias. Remember. Okay. Normally for amplification purpose, we always prefer to use in active region. But for specific purpose, we can use the transistor in saturated region and cutoff region. That's what we will discuss later. Okay. This is the basic term. Finally, what is the moral of the story? Moral of the story is that transistor is a T-terminal devices, and one output terminal is always referred. One is a terminal is collector terminal, one is the emitter terminal, and this is a basic terminal. Okay. And total current is this equation, irrespective of any combination. Total current is remain fixed at the junction as per Kirchhoff law. Clear? And there is a alpha beta gain. Alpha is associated with common base, beta is associated with a common. Okay, and common collector, yeah, I'm not going to calculate the gain in common collector. Common collector normally not used for amplification purpose, it is used for impedance matching. That's why I'm not going to calculate the current gain parameter in common collector. Okay, and suppose I am giving another example. So transistor normally it is look like that. Transistor is look like that. It is 3 terminal device, base terminal. This is base terminal, is 2 terminal. Okay. Then it is 1 terminal. 1. In laboratory, you will get 3 terminal. Okay, how can you identify emitter, base, and collector in laboratory for practical purpose? So transistor, this is IC 2N2. This is IC number. IC number 2N414123. This is IC number. Okay. Whatever IC, the transistor. If we take a transistor in laboratory, you will have a T terminal. Okay. So one is a base. Base is the longest. There is a T pin like that. T pin like that. Longest length is the base, middle position. Okay, base. And T, and second longest is the 1 emitter. And second smallest one is a collector. Okay. This is how we can identify. And next class, in the next class, we will discuss load line analysis of transistor. Load line analysis means in order to apply transistor in for different application for AC analysis, and then we have to analyze the DC analysis first. So DC analysis, if we DC analysis means we are applying DC voltage to the transistor. We try to extract the behavior of transistor. Transistor behavior means at what voltage it can operate accurately, at what is the maximum current rating, what is the maximum voltage, maximum power, and all the information we will get from the DC analysis. Once we know the DC parameter, after that we will move from it for AC analysis. Okay. In the next class, we will discuss the DC load line analysis, DC biasing of transistor, BJT, bipolar junction transistor. After that, we will move for some basic of hybrid model, how we can calculate the transistor shortly, circuit analysis, amplifier, push-pull amplifier, different combination application of transistor for amplification purpose and combination. We will discuss it. That's the next class. Okay, thank you.